box. I'm just a blue box. Oh my goodness. All right, guys. As you come in, let me know if you have any questions. No question. What happened? Oh, all right. Train just pulled in. What was that? Did you guys hear that, or was that in my head? I don't know. It sounded like a train. Okay. Weird noises. No questions? Everybody's doing fantastic on the homework. You're all ready for the quiz that's happening Monday. You've all tried out the practice quiz if you want to.
Question.
All right, well, let's see. Hello? Yes?
On 6.1, is that okay?
Wait. On 6.1, what?
On 6.1 homework, I did have a question on one problem.
Okay.
I'm probably just overthinking it, but for number 12, it's what is the z-score of x equals 9? Do we just plug that into the formula?
All right. I love this. Somebody was asking me this earlier. Let me show you guys this. Of course I would love this shit. The first several problems of 6.1, there is basically no work. Can somebody tell me right now, and let me really give you a reason to answer this question now. This question is going to be on every quiz from now on. I used to do this on every test. Now I'm just going to do it every damn quiz. This question will be on it. You ready? So I am telling you right now, I am telling you a question that will be on the quiz, and then we'll talk about what the answer is. And I hope to God, maybe I can get more than half of everybody get it right. Yes. So can somebody tell me what a z-score tells you?
Number of standard deviations from the mean.
To the
Left.
Mean.
no.
Mean.
So the number of standard deviations from the mean to the
mean.
from the mean to the mean, then it's always 0. No. So
Mean to
the
the
number of
value.
yes, from the mean to the data point, whatever data point you're making a z-score for, right? So let me say that again. A z-score always tells you the number of standard deviations from the mean to a data point. That's why z-score. So for me, I don't think I've said this yet. Maybe I have. Standard deviation is like inch or centimeter or foot. It's the unit of, it's kind of like the tick marks. A z-score is when I lay down the ruler or the yardstick or the whatever the hell and I read it. So if I said I am 5 inches away from that wall over there, or I am 5 miles away from the nearest Denny's or whatever. Why did Denny's? Who cares? It doesn't matter. I've chosen different units based on how spread out those things are in general, right? I would use appropriate units based on how spread out things are. So that's what a standard deviation is. It's like a tick mark on a ruler. And the z-score is the actual measurement I make. So coming back to this question, it says, this is number 12, what is the z-score of x equals 9 if it is 1.5 standard deviations to the left of the mean? And what's a z-score tell you again? What's a z-score mean?
The number of standard deviations from the mean to the data point.
I like it. That was in stereo. Kick ass. And so can you guys see that the problem basically tells you the answer directly? There's no work. Can anybody see that? If I know the number of standard deviations away something is, I know the z-score of that thing. There is one thing to be careful about though. So it's not, the answer is not 1.5. It's almost right.
Negative.
Yes.
Negative 1.5. Done. Next. Thank you. So that is a problem where the better you know that definition, the easier it was. They didn't give me enough information to use the whole formula. Right? I don't know what the hell the mean is. I don't know what the hell the standard deviation is. How the hell am I going to use that formula? But they actually just gave me the answer instead. I'm like, book, do that whenever you want to. It's great.
Is it negative because it's to the left?
Yes, totally.
Gotcha.
Like, because the mean, if I make everything a z-score, what will the mean always be? If I make everything z-scores, the mean is 0, which means one side's negative. Anything below it is negative. Anything above it is positive.
Gotcha.
So whenever you have a quiz or a test, you definitely want at least a positive z-score, if not a large positive z-score, right? That's what you're desiring for a test or something. Okay, I like it. Anything else from homework, guys? That was a good question, because those are weird. Sorry?
78D,
In 6.1?
6.2.
2. 78?
Yes.
Blah, blah, blah. This one about President Clinton.
Mm-hmm.
By the way, for you youngsters out there, that's Bill Clinton, not Hillary. Hillary was never president, so don't wonder about that. That's from such a long time ago. Blah, 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 blah. So they give you, so what do they give you? They give you the average.
Mm-hmm.
They give you the standard deviation, kick ass. Was bell shaped, so you know it's normally distributed. That's what they're trying to tell you there. So the approximate distribution density. So you want 78B. Is that a population mean or a sample mean?
Sorry, D as in dog.
D, I'm sorry, D, okay. Yeah, so on part D, what was the problem? Because if you could do part C, part D is the same idea. So what was the specific issue here? Because if I drew this distribution, go ahead.
Yeah, I drew it, I worked it out, and my answer just doesn't seem right. I don't know if I'm plugging the,
What'd you get?
the information in. 0.1383.
Yeah, well, it could be 13.83%.
I got the same thing.
Okay, that sounds good. I'm not saying it's right. I have no idea. I don't have the little magic book here right now. The magic book with the answers. But I mean, that's a completely valid possibility. I mean, think about this for a second. All right. Do either one of those numbers get very far away from the mean?
No.
2000 is pretty close. 1800 is pretty close, especially considering now, remember what I said, I made a big deal out of this. You can't talk about close without knowing how big the standard deviation is. Standard deviation is 500 something. So that's only 100 something away. That's only 50 away. So they are remarkably close. As I it's not COVID. So yeah, it makes sense that it's going to be kind of a tinier percentage because it's not really far away from the middle. So you're going to get a little sliver in the middle. Is that all right? Why did it seem weird to you? Was it because it was small?
Yeah, I don't know. I just I think it didn't match with when I drew it. Like I feel
Oh
like
yeah, so your drawing is not going to be to scale more than likely.
Mhm.
So you can't, especially when it's something around the middle. If it's something like in the tail or something, you can pretty much know it's going to be small. But when it's around the middle, you don't know what the scale is supposed to be. So you can't really tell that well. All right.
Okay. It's good. Thank you.
You're welcome. How's everybody else? Anybody else? Going once, going twice. Okay. Stop sharing that. Let me continue to die. I don't know what's going on. All right, so I want to do this before we get into new stuff. I've got up on Canvas. Let me show you this. All right, I guess I'll do, well, let's see. If I do this, can you guys see Canvas now? Yes, okay,
Yes.
thank you. So if you go to modules, you will notice, for example, if you go down to unit 6, there's the practice quiz thingamajig. And then there's a couple of new things here in unit 7, chapter 7. So that's where we're about to go, sort of. I'm actually going to do, one of these has a bit of a, what do you call it, Jeff? You can do it. Review. So one side is all this freaky blue and yellow shit. Go past that. So go to Canvas now if you can. Go to the module, unit 7. Oh, where'd you go? Get back here. There. And go to sampling distributions. That's actually the new stuff we're going to talk about today. That sounds exciting. And on the back side of this are some review questions. There they are. All about rent in New Zealand. I'm not saying that I'm considering moving in November, but you never know. But so, is everybody able to access that one way or the other? Or does somebody need me to share this on the screen? So I want you to do this. By this point, you should have printed out the Z-score charts or have them easy access, easy access to the Z-score charts, right? Oh, here comes the chat. Where's my chat? Come here, chat. There you are, chat. Oh, cool. There you go. All right. So let me see if anybody else, if I do this. So I want you to work on that thing that I just had up there. Do it. Is anybody not able to work on it right now? Are you guys able to work on it, everybody? Okay. Just let me know if anybody needs the Z-score chart up there or this handout. Just, you gotta let me know. And if anybody else is feeling like it would be okay to turn on your camera, that would be great. You don't have to. I can't force you to. I just miss seeing people. There we go. There's somebody. Hey. All right. Here, I can stop recording. This is not something we need for later. Again. Let's see. So real quick, just to catch up with you guys on this problem. If I draw this picture, so I know it's approximately normal, so I'm allowed to do this picture. What goes right in the middle?
0.
966.84.
All right, Janik, I love it. It's always like you're playing on a game show or something. You're like, I got it. I have no money. I can't give you any prizes. And what I'm curious about 930 and 1200. So I'm going to slap those bad boys on here. Now that's obviously not to scale. I mean, look how far apart those are, but I don't care. I just need kind of a visual to keep track of what's going on. So let me stop for a minute. So everybody okay with that? So the reason the middle's not 0 is because these are not z-scores. I could put underneath here in parentheses 0 because that's what the z-score would be. So of course the next thing I've got to do is what?
Find the z-score.
Yeah, if I can convert these to z-scores, why is that good?
You can find the area.
Yeah, I've got a sheet of answers. But the sheet of answers can only be used if you have the z-score. It's almost like a quest. The sheet of answers, but you need a z-score. So we have to first get z-scores, so then we can use the sheet of answers. So yeah, so the question I just got was related to this. When I write this formula, people will do this quite often. This has already happened. They will put this in the calculator and they won't put this in parentheses. But of course it has to be in parentheses because you have to do the top and then divide the bottom. That's what it means when I have a big ass division bar. Calculator can't see the big ass division bar. All right, so let me do that with you guys. Should I put my, no, I'm not gonna pull my calculator up. What do you guys get for that?
Negative 0.27.
Man. All right. That's enough for right now. Keep going. Get this done. Share this screen. So hopefully that was enough time to discuss a decent chunk of this stuff. So on this first one, I got 930 converted to negative 0.27. I just have to convert 1200 now. So if I convert 1200, what do you guys get for that z-score?
1.70.
Does that sound right, everybody?
Yeah.
Yes.
Thank you. Verified. And then, so now that I got those z-scores, and we know that we never ever freaking subtract z-scores ever, we now look up the areas in the chart. Why did I do this? Oh, well, it's too bad, Jeff. Pretend like that's not there. This is going here. This is going here. So when you look up 1.70, let me look it up too. 1.70, that's what I get right there. Is that what you guys got? 9554.
Yes.
Coolness. Let me write this in a different color. Let's see. Let's not do blood red. Let's do purple. Why not? Is that what that is? 9554. And then when you look up negative 0.27, what do you guys get?
0.3936.
3936. Kick ass. This might seem nitpicky, but be careful. These are not z-scores in here, right? These are areas. These little dudes in purple are areas. All right. So now to find the actual area I want, I just have to subtract these two. And then, you know, whatever the hell I get. Let's see, that's going to be
5618.
5618. Yes, it looks about that. I don't know why I'm writing it so crooked. So about 56%, a little over 56% chance that you'll find a 3-bedroom flat between $930 and $1,200 a month. These, by the way, are converted to like American dollars, right? Okay. That's kind of unheard of here. You'd be lucky to find a closet that costs that much a month in San Diego. Yeah. Okay. I mean, if there's a closet work for them, I'm like, that's great. I'll live there. Oh, let me see. Somebody's chatting. It's a great deal. That's right. All right. What about this guy? 95th percentile rent. Where would that be on the picture?
The left.
So 95th percentile means there's supposed to be 95% of the picture below it. So if it was over here, that wouldn't make any sense.
Be to the right. Oh,
It's got to be up here, so it's got a full 95% below it. So if I can figure out this guy's z-score, I can then figure out the actual money for rent. Okay. So how do I figure out this guy's z-score? Well, I do the exact opposite of what we did up here. Instead of looking up a z-score on the outside and getting the area on the inside, I start with an area. So I start on the inside, 0.95, and this is that special situation we saw the other day. It's going to be right in between 1.64 and 1.65. So if you follow the little thing down here, I get 1.645. That's crazy. They just split the difference. 1.645. That is the z-score for this. But I want to know a rent. So how do I convert that back to a rent?
you would plug it into the formula to find x.
Yeah, so we got this backwards formula. It's the z-score formula just solved for x. We got this dude here. So I use that when I know everything except x. So it'll be 966.84 plus 1.645 times, what was the standard deviation? There it is, 136.91. Sorry, problem. So I just got to throw that bad boy into the calculator. And you get something.
1192.06.
1192.06. That's pretty damn good. So 95% of people living in a 3-bedroom flat in Waikato, New Zealand, in the Taupo district. I mean, that's a little specific, but they pay less than 1192.06. Did this guy come out weird? Is that what's going on?
Yes.
Yeah, I know he would. So this is still 966.84. I want the probability it's greater than 1600, but when you try to convert that to a z-score, what do you get?
4.62.
Yeah, somebody remember what happens when it's off the chart? Anybody? And what's the chart say?
It says that for 3.50 and up, it's 0.999.
Yeah, so officially you could say, so what would the answer be then by the book? What's this side?
0?
No. Close. So if you do it by the chart, that would be your answer. My answer would be about 0. So if that's what you meant out there, I agree with you. But if you go by the chart, you get 0.0001. So $1,600 is so far away from the expected amount you would pay that it's essentially nobody pays more than that. Or maybe one person. All right, let me stop for a minute. Is that all right? Okay. Let me see. Let me change colors. Doot, doot, doot. So now we go to San Diego. Oh, shit. And the numbers got a little bit larger, just a tiny bit larger. So now I want to know the probability that it's between 2,000 and 3,000. So the mean is 29.23. I want to know between 2,000, come on, there you go, and 3,000. So just like that first problem, I have to make a z-score for both. So has anybody done that yet? 2000 minus 2923 divided by the standard deviation. That's my z-score formula, right? Don't forget your parentheses. Oh, birds flying all over. Let me see, 2000, 29, 23. Whoa, Jeff, not 20,000. Let's not go crazy. I mean, that's La Jolla, 20,000 a month. 352.21. 352.21. Spare him his life from this one. So do you guys get negative 2.62?
Yes.
Yes.
All right. So either I did that right or we all suck. And then you would just do the whole formula again. You have a 3,000 there. Has anyone did that? Has anyone done that? There's grammar.
Point 20.
Good. I got 2 people who want to do it. Point what now? 20,
22.
22. Yeah. Somebody tell me the answer in chat. Yes. Thank you. Thank you. Okay, so there's my z-scores. So if I look them up, I get the area there. It's too much. I get the area there. That's how much I got to subtract to get the area in the middle. I like it. So when you look up, let's do this real quick. Negative 262, you get shaboo, 0.0044. And when you look up positive 0.22, oh, Jeff, you doof. I just closed the poor thing. There we go. When you look up, what was it? 0.22? 5871. Yeah. So this whole area is 5871 and this little area is 0044. So the area in the middle is the difference between those two. 5827. Is that right? So that's the same problem as the first problem. It's the exact same problem. Numbers are different, but who cares? The problem's the same. And then where would 15th percentile rent be? Where's the 15th percentile rent?
On the left.
Yep, definitely, because now it's only supposed to have a little 0.15 down there. So this will be the rent that only 15% of the population pays less than that for a 3-bedroom apartment. So I need to first figure out the z-score, and then I can use that backwards formula to figure out the rent, just like before. So what's the closest you can get to 0.15? And obviously I'm going to use the negative z-score chart. It's below the mean. It looks like it's going to be Columbus. See if you agree with me about that. Anybody else get Columbus? Yeah, somebody else got Columbus. This shit am I talking about? I'm talking about 1492, right? That's the closest I can get to 15%. So that's negative 1.04. So everybody see that? So 14 is negative 1.04. It's that. That's the closest I can get to 15%. So that z-score is negative 1.04. Get that, gummit. And now I can just throw that in the old formula. I got a mean of insanity plus, and actually it's going to be minus because it's negative 1.04. Sorry, problem. You're just going to have to get way over there. Times 352. I see a chat. Hold on. Ha ha ha. Oh, good. Oh, thank you. You never have to understand my jokes. It's fine. And then you get whatever the hell. I would guess this to be 2211. It's a complete guess. I have no idea. That's so bad, Jeff. That is nowhere near right. Let me change my guess. Why did I do that? That was really bad.
2,556.78.
All right, fine. Don't let me try to change it.
Oh, sorry about
2556. No, you're okay, man. 2556.78.
78.
I don't know why I doubled this, but oh well. Yeah. So that means that 15% of people would pay less than this for a 3-bedroom place in San Diego. Sounds about right. And then just to cut to the chase on this bad boy, if you try to make 600 into a z-score, 1600, sorry, become a 16. If you try to make a z-score out of that, what do you get? Dadgummit, get in there.
Minus 3.76.
Yeah, and that's off the chart. So you can either use 0.0001 as your answer, or you can say about 0%. Either way. So in San Diego, almost none of the places are below 1600. And in this district in New Zealand, almost none of the places are above 1600. Of course, you probably get a lot less money when you work jobs there, but still kind of averages out. Probably better. Okay. So we've
Can
done,
you
yes, sorry.
explain how you got 0% for C for 2?
Are you cool with the 0.0001?
No, how'd you get that too?
If you look negative 3.76 up on the chart, do you see
Oh.
how it's not even on the chart? And what's it say? It says 0.0001 for anything negative 3.5 and lower. That's the area.
Okay, thank you.
You're welcome. Okay. All right. That's enough of that. So we've done plenty of examples of z-score problems, which is good because you got to kind of get this pretty decently well before we get into the next thing, which we're going to do right now. So I'm going to stop sharing. Has everybody got what they want from this mashup of colors over here? All right, that's enough of this. Let me stop sharing that. Okay, so the quiz on Monday will be on chapter 5 and 6. So that's uniform distributions and normal distributions, right? Okay, so let's do a little bit of chapter 7 and then call it a day, maybe a little bit early. Why not? Because they don't really give us a break because I'm evil, and then I let us out a little early, so I hope that that averages out. So the idea in this chapter is really kind of funky. I am going to very quickly turn my AC on because it's freaking hot. Yeah. All right. You're gonna, all right. I was about to say something. I was gonna say you gotta go with me, but that's all you ever do in my class is try to go with me. We are gonna take a trip to alternate universe, Florida. Or some make-believe place, okay? So it's part of the multiverse somewhere. It's not C-137. So if I had a wherever it is, some fictional place, and the ages look like this. So what the hell does that mean, Jeff? That means that there's nobody here. So let's say the average age is 40. Let's just make some shit up. So this is what the distribution looks like. And this is, I'm gonna pretend like this is Florida. So I got a lot of young people and I got a lot of old people that are retired and nobody in the middle, right? Just the way it is. It's some weird Logan's Run thing where you only kill people in the middle. All right. So this is a possible distribution. It could be true somewhere. There could be a place that this is basically true for. I don't know. Let's just say that's what we're working with. And the standard deviation is whatever it is. So I'll just put sigma down there just to, it's whatever it is. So how did I really want you guys, all right, how would I create this? If this wasn't created yet, how would I actually go about creating this? So what do these represent? What would this dot right there, what would that represent? And I love this question.
A data point?
A data point, I love it. And so somebody remember, let me put the little title up here. This is ages of people in alternate universe, Florida. So that dot represents the age of a person, right? So how did somebody construct this distribution? I said, hey, you, how old are you? Really? Okay, and I put the dot. And how old are you? I'm 2. Okay, I put the dot. How old are you? I'm 87. Okay, I put the dot, right? And I just keep going. I just keep going, just keep going, just keep going until I go insane. So let me stop for a minute. Is that all right? You guys understand?
I know you're not gonna like it, but whatever.
Why?
Say again? What?
Whatever.
Thanks. Can I have a towel, please?
I'm gonna mute you. Okay. Can we only unmute?
It
if
makes
we have-
sense.
What's happening?
It makes sense.
Okay, thank you. All right. And I haven't done much yet, but I really want you guys to understand this much by itself. Now, so I constructed this by taking one person at a time and saying, how old are you? And I plotted them and keep going. What if instead of that, I took 20 people at a time? So I don't ask one person how old they are. I take 20 people and I say, figure out your average age and tell me. And then I plot that. So I am plotting averages of samples of size 20. What's going to happen more than likely? Is it very likely that I'm going to get a bunch of people all right there? If I take 20 random people, is it very likely that they'll all be 3 years old?
No.
No. Is it impossible? No. Is it likely? Nowhere near. It could happen. It'll happen, but not very often at all. What is the most likely thing that would happen? Let me see if somebody can get this. If I take a group of 20 people, what's the most likely thing that would happen?
Some on the left and some on the right.
I love it. A mixture. What's the most likely average age of any group of 20 people?
40?
30
40.
something?
Yes.
40?
Sorry, say again?
40.
Are you agreeing with me? Yeah, I love it. Because that's expected value. That's what I expect on average from any group I take. But does that mean every group is going to have an average of 40? No, it doesn't. So now when I graph the new picture, I'm not going to graph individuals anymore. I'm going to graph X bars, right? I'm going to graph sample means. So this is a graph of X's, data points, This will be a graph of X bars, sample means. So what's it going to look like? Well, the most likely thing is I get the mean. So that's going to be the highest point. And then sort of the next most likely thing will be just a bunch of old people. And the next most likely thing will be a bunch of young people. So maybe it'll look like that, just to take a guess. Let me stop for a minute. It actually would look better than that, but I don't care. I'm not going to redraw it. All right, let me do this one thing. That won't be that bad. Be like that. Okay. Now tell me this. Does that new distribution look more normal than it did at the beginning?
Yes.
Yes. It doesn't look normal exactly, but it definitely looks a lot more normal. Also, does it make sense that the average of each person will equal the average of each group? The average of all the groups, right? If I average each person one at a time, I get 40. If I average every group of 20's averages, I'm still going to get 40. It's still the same people, right? They don't suddenly age because I put them into groups. That would be weird. Come over here. Okay. Oh, God. I'm feeling. No, not good. Okay. Maybe. So the mean stays the same. But which one of these has a smaller standard deviation? Which one of these has a smaller standard deviation? If you remember what standard deviation means.
Second one?
Second one definitely has a smaller, because what's standard deviation? It's the average distance from the mean. So which one of these stays closer to its mean? This one does. So look what I'm going to do. You ready? I'm not going to use that same symbol. I'm going to use the standard deviation of the sample means. That is one symbol. That's a little subscript. So the standard deviation of the sample means will be less than the standard deviation of the population. So it's kind of related to, if I ask you, would you really like freak out a lot if you went out, come on Wi-Fi, am I doing okay? Would you really freak out a lot if you picked one random person and they were 87 years old? Would that like freak you? Go, oh my God. Would that freak you out? No. What if you picked 20 random people and their average age was 87? Would that freak you out? Think about it. What would you do? You'd stop and go, what has happened? What has happened? These are random people. How the hell could they all be that old? So that's what this is related to. This is all about, it's going to be very unlikely to have a group very far away from this, nowhere near as likely as it used to be, because the standard deviation has gotten smaller. So here's the trick. Here's the cool thing. Once you get to greater than 30, your picture becomes normal, or normal enough. Let me say it like that. Normal enough. Normal enough for what? What was the big thing with chapter 6?
Z-score?
Yeah. No, be careful. I want to be really careful. I'm glad you said it like that. I can always calculate z-scores, but they have to be normal for me to do what with the z-score?
Find the area.
Find the area. I love it. I can't use that chart of answers unless I know it's normally distributed. I can make z-scores all day for anything, but they won't translate to a specific area unless I know it's a normal curve. So now I have a check. As long as I'm taking samples greater than 30, it doesn't matter if the original population was disgusting. As long as the sample sizes I'm taking are greater than 30, I've got a normal curve. I can use my list of answers. Yay. Yay. Okay, maybe. This is all weird. I totally understand. All right. So that is the concept behind what we're doing. Let me show you a concrete example of this instead of alternate universe Florida with weird ass things that I'm drawing. All right, so that's what the other side of that handout is. The most colorful handout I've ever made, and it's got 2 colors, and that's kind of scary. No, I think the most colorful had 3 colors. All right, let me get that back. What's happening? I love you guys. All right, let me see. Where'd it go? There it is. All right, where'd you guys go? There you are. All right, so let's come back to this thing. Bam. So that's the thing we just did with the New Zealand and all that kind of stuff. And here, let's go back to this side. Oh, shit. Okay, here we go, guys. Here we go. This is a concrete example of this thing I did. So here's my original population. So my population, I put the numbers 1, 2, 3, 4 in a hat. So here's my population. Here's what it looks like if I graph it. So if I put 1, 2, 3, 4 in a hat, they all have a 1 out of 4 chance of happening, right? So that's what it would look like. So it's a nice uniform curve. Excellent. Oh, what happened to you? Don't tell me no. Oh, there it is, okay. Poor little dude stopped working. So that is kind of like alternate universe Florida, except it looks a lot better to start with, right? A uniform curve is really nice. It's symmetric kind of in the most basic way. Of course it's symmetric, it's a big block. So what I'm about to do, so up here, what did we do? I know I'm a little tiny box for you guys now, I'm sorry, but up here, didn't we have a original population, and then I took samples from that population. So that's exactly what I'm gonna do. I'm gonna reach into this damn hat, and I'm gonna pick out all the possible samples of size 2. Let's do size 2. And you can imagine, why am I doing 2 and not like 3 or 4? Because then this would get crazy big. 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 1, 3. Holy shit, let's just do 2. So up here, what did I do? When I took samples of size 20, it was up here, I found their average, and then I worked with it. So is everybody cool with what these are all about? The 1, 1, the 1, 2. Is anybody not cool with what the shit those are?
I'm a little confused on those.
So in my hat, is everybody cool with this? Let's start there. If I have the numbers 1, 3, and 4, if I have those in a hat, they each have a 25% chance of happening, right? So these are all the things that could happen, and there's a 25% chance of them happening.
Yeah, I understand that part.
Okay, cool. And then if I do the mean and the standard deviation, I get those things. We'll come back to those later. So that's like the mean and standard deviation for the original. So now, instead of working with one piece of paper at a time, instead of just working with data values 1, 2, 3, 4, let me work with the sample means of every sample of size 2. So I have listed all the possible samples of size 2 I could get. If I reach into that hat and I pick one number and then I drop it back in and I pick again, aren't these all the things that could happen? I can pick a 1 and then a 1 and then a 1 and then a 2, right? Is that cool?
Yeah, I understand that.
Okay, okay. And please let me know if something doesn't make sense, because this is definitely a little strange. What happened to my, why are there no lines there? All right, whatever. Being all freaky, PDF. All right. So now I'm going to just do the average. What's the average of this sample?
I have a quick question.
Yes, yes.
What does it mean by like size 2, like all samples of size 2?
So I'm going to pick, so it's sort of like if I said, let me go take a sample of 7 people, you would go take 7 people, right? If I said, go take every sample of 7 people you can, you would then take 7 and then put them back in and then take 7 and then put them back in, take 7.
Okay.
A sample of size 2 means I'm going to pick the paper out twice. That's all.
Okay. Okay.
Yeah. So it's sort of like 2 people, but now they're 2 pieces of paper. So let me do this real quick. Up here, I had original population was the ages of people in Florida. Then I took every sample of size 20 that I could, and I got this picture when I plotted those means. So if I got one sample of size 20, I said, what's everybody's age? Got the average, put it up there. So coming back to this page, to do a concrete, real example, I had to kind of like make it smaller sample sizes so we could do it by hand easily, right? So here's one sample. I could reach in and get a 1, and then I could reach in again and get the 1 again, right? That's possible. And what would the average be of what I got then? So really all I'm asking is, what's the average of 1 and 1?
1.
1, that's crazy. What's the average of 1 and 2?
1.5.
Yeah, okay, keep going. So I'm just averaging each possible sample that I could get. So the average of 1 and 3 is 2. You'll see a pattern emerge. See how it kind of goes up by half each time? The average of 2 and 1 is the same as the average of 1 and 2, which is 1.5. And then it goes up a half, and then it goes up a half, and then it goes up a half. And if you don't trust me, you can do the averages. People that are really good at math realize that fundamentally it's all about noticing patterns. So I have a lot less work to do because I notice that pattern. And then the average of 3 and 1 is 2, and then it goes up by half, and it goes up by half, and it goes up by half, right? And then the average of 4 and 1 is the same as the average of 1 and 4. It's 2.5. And then it goes up by half, and it goes up by half. And then the average of 4 and 4 makes sense. It goes up by half to 4. All right, so now, this is everything in yellow is now my data. They are my data points now. They are sample means, they are my data points. So what I've done is I've put it in this form down here. And what does that mean? How many ones are there up here? How many sample means of 1? How many sample means was 1?
1.
There's only one of them right there. 1 out of 16, right?
Yeah.
So see how that, isn't that where that's where the 0.0625 came from. Jeff, you're not using that, dude. You can go over here. Bam. So this was 1 out of 16, which is 0.0625. This was, how many 1.5s are there? 2. 2 out of 16. How many 2s are there? 3. How many 2.5s are there? 4, and so forth. So what I'm doing is I'm doing the actual work behind the pictures I put up on the board. And of course, we didn't have the ages of all these people in Florida to work with. And I wouldn't want to do that. That would be disgusting. So I created a new problem. I said, let's only have 4 data points. And then let's pick samples of size 2 so it doesn't get too big. But we're doing the exact same thing. Instead of working with the data values, I'm going to work with the means of all the groups that I picked. So that's my new data. That's what my data now looks like. Now, I want to remind you, let me show you something. Now look, do you see down here how I calculated the average and the standard deviation, right? Let me show you how I did that. So I'm going to stop sharing for a minute. And I'm going to share my calculator. So if in your calculator you put, let's see if I can do this semi-quickly now. So I'm going to put this data in there real quick, just to remind you guys how this works. 1, 1.5, 2, 2.5, 3, 3.5. Jeff, that doesn't work. 2.5, 3, 3.5, 4. And then I put in there the P of X's, 0.125, 0.175, 0.25, and then it starts to repeat as it goes back down. No, Jeff. Why are you doing that? There. And then 0.062. 0.06. I can do it. I'm going to do it. It's going to be amazing. There we go. Right? So if I do, I think I showed you the shortcut before. If I do stat calc 1 var stats and I tell it the frequency list is L2, that's my X's and my P of X's. It'll tell me the mean and the standard deviation. So that's where I got those from on the sheets. Let me go back to the sheet. Pew. Shit. There it is. Okay. So much technology. There we go. All right. All right. So something I want you to realize. You saw this just happen. You saw this is what we got. Here's something interesting. Here's what the standard deviation used to be. 1.118. Got so much stuff around here. Let me get rid of all this crap. Go away. Just go away. Go away. Right here, right? That's that's the standard deviation of the original data values. What is 1.118 divided by the square root of 2? My sample size was 2. Can somebody do that? What's 1.118 divided by the square root of 2?
0.7905.
Which is exactly what we got for the standard deviation for all groups of size 2. So can somebody, and that's exactly what I point out over here. So if, instead of taking samples of size 2, if I would have taken samples of size 3, then my new standard deviation would have been the old one. What was it again? 1.118, yeah. It would have been 1.118 divided by the square root of 3. If I would have taken samples of size 4, I would have divided it by the square root of 4. Because do you want to have to do this shit every time you have a problem like this? No. I would much rather have a shortcut way to figure out what the new standard deviation is for my new picture. And look at my new picture. Look at this new picture. Does that look more normal than it used to look? In fact, does it just look normal, period, this picture? Yes, Jeff. I don't know. Everybody's working on something. I appreciate that. All right. Okay, maybe. So what's going to happen? So just so you know, we're not going to do much more. What this means is this. Let me see if I can sneak a very quick problem in that shows you nuts and bolts. This is not going to be your homework at all. This is me doing extra shit, trying to show you where this stuff comes from. So here's what a homework problem would look like. Because if I'm in this class, if I were one of you, I'm sitting there thinking, what the hell am I going to have to do for homework? Am I going to go to alternate universe Minnesota, Jeff? No, you're not. Or, if you do, let me know. I want to know about that. Grab me, I don't know, alternate universe Minnesota merchandise. So watch this. If I know, so if I'm given that the mean of something is 14 and the standard deviation is 7.19, we take a sample of 38 data points. What's the probability that the sample mean is more than, less than 13? All right, I can't see you guys. Let me see, where are you? There you are. All right, doesn't this feel like chapter 6? There's only one difference. So they gave me a mean, they gave me a standard deviation, they're asking me the probability less than 13. There's two different things. I took a sample of 38 freaking data points, and the question is about the sample mean. So when I take a sample and the question is about the sample mean, I have to change my standard deviation. I cannot use this one, and I really want this to make sense. Why? This one tells me the spread of individual data points. I need the spread of a group of 38 data points for this problem. This won't help me worth shit in a problem that's not about individuals, because that is the spread of individual data points. Is my Wi-Fi freaking out? All right. So when I take a sample of some size, I cannot use that spread that they give me. I've got to figure out what's the spread for a group of 38. And how do I do that? I take this dude, Jeff, and I divide it by the square root of 38. That's what we just figured out. So what the hell is that?
$1.166.
Like that? Did I? No, you're probably right. Why did I put 7.18? 1.166. Yes, you're right. And so this is the only new thing. This is the only new thing in chapter 7. Because then what do? I draw the picture. I put the mean in the middle. I put down my data point, shade in my area. I make a z-score. But when I make the z-score for 13, I'm going to do 13 minus 14. And I'm not going to use this dude. I have to use this one, the one that works for a group of 38. So the actual work is going to be about the same. So I get negative 0.9. And then you would look up negative 0.90 and get the area. So the only new thing in chapter 7 is, chapter 6 was we're dealing with one thing at a time. One data point at a time. Chapter 7 says I'm dealing with a certain sample size. So I have to change the standard deviation into the one that works for a group of that size. And this is how I do it. Then I can do my z-score and shit, because now I've got the right spread. Now I've got the right standard deviation. Woo! Okay, that's a lot. So that's awesome. We'll obviously go back over a big chunk of that next time and do example problems like crazy on that next time. But I think that's enough for today. Does anyone have questions or anything you need to hang out for a bit? Oof. My back. My back hurts. Is everybody all right? Anybody? I'm gonna, yeah, I will have a good weekend. Extra shit, certainly. Thank you for that.
Just a quick question. So for the quiz on Monday, it's going to be chapter 5 and chapter 6, pretty much. Okay. Awesome. Thank you. Have a good weekend.
And normal stuff. All right. I'm going to head out. I don't see any more questions. I'll see you guys later. Oh.
Hey, it's Ian.
Hello?
It's Ian. Can you hear me?
Yes.
It's Ian.
What's up? Yes.
I was just curious about the quizzes I missed. Am I able to still make those up, or is it?
Oh, let me see.
Recently, the last couple weeks, I've been having issues with my computer, and it, like the screen, basically split from the backing of the top part of the laptop.
Oh, shit.
Yeah.
Let's see. Which quiz? Yeah, you did miss some quizzes. Where are they at? Come here, quizzes. There you are. So you got the first one, but I noticed, well, all right, so, wait, Ian. There you are. You missed the first quiz, is that right?
Yeah, that one, that was all my mistake.
You got the second quiz, and then you basically missed every other quiz. Okay. Yeah, if you shoot me an email and remind me, I can make some makeup quizzes. Let me see. 1, 2, 3. 3. So you need 3 makeup quizzes. Okay. Yeah? Can you do that?
Yeah, I'm currently trying to catch up in all my classes right now because of my computer being down for the last 2 weeks or so.
Yeah, you just got to let teachers know when that kind of thing happens so we know what's going on. Right?
But I didn't have access to anything. I couldn't remember my password to Canvas on my phone.
You got my email, right? I don't know. Yeah, I don't know if you couldn't access anything. But yeah, so just email me and remind me to do that because I'm not going to have time right now. But and knowing me, I'm going to forget.
Okay.
Okay. Janik, are you okay?
Yeah, I just have one quick question. For 78B on 6.2, it asked me like whether the mean was a sample mean or a population mean. I put sample mean because it was only talking about like the districts in Alaska. Is that wrong?
Well, that's the point. That's the population is Alaska. And that's why they say there's only 40 election districts so that you know it's not just a sample. They took all the election districts in Alaska, yeah. So it's definitely a population mean.
Oh, okay, thanks. So 78B was population mean.
Cool. All right. All good? I'm out of here.
Yep.
Okay. Take care, man.